Hey, good morning, everyone. If anyone has a hangover from yesterday, please let me know. I'll talk slower. And I anyway try to do it as short as possible. So a few words about myself. My name is Dudi Cohen. My real name is David, but nobody calls me that. I'm Rookout's VP of R&D. I basically manage our R&D. And I'm a debugging addict. I love solving problems. I love solving my employees' problems. I love debugging my own code. And in Rookout also I love debugging our customers' code. But that's another talk. I'm also a low-level geek. If you want to talk about reverse engineering, bytecode manipulation, whatever, just ping me later on. A few words about Rookout, just to give you all the background. We're doing dynamic observability, which is quite new in the observability area. We allow our customers to collect data dynamically in real time from production, from staging, wherever they want it. Again, if you have any questions about it, talk to me later. So I want to share with you my small journey investigating tracing. As my work in Rookout, apart from managing the R&D, I'm also meeting customers. I'm meeting potential customers. And about 2 years ago, everybody started talking with us about tracing. It was tracing that, tracing there. Do you have tracing? We need tracing. And we try to understand, I try to understand, what are they talking about? Why do they need tracing? Do they know what they need tracing? And I mean, we had tracing in Rookout. All of our backend is instrumented with tracing. We use tracing, but it seemed like the crusade for tracing, or the hype for tracing, was really a success. So I tried to understand, why are they talking with us about tracing all the time? So for most of us, when we're talking about tracing, we're thinking about something like this. An amazing system with a lot of data that allows us to know everything everywhere about our application. And that pretty much means that when I see a request going in, I know where it comes from. I know every step of the way what happened with my system, what happened with my requests. If I had an error, I know exactly where that error happened. I know latency. I know everything. I know everything about everywhere. And that's the promise of distributed tracing. But when I started to ask a lot of questions, also in how we handle and how we look at tracing, I understood that it's not really always acting like that. And I'll try to give a little bit background about tracing, as far as I know it, to start and talk about tracing. So nowadays, when people say tracing, they actually mean two things. And to be more exact, the two things are very different. The first is request tracking. I think most of us know what request tracking is, but I'll give a brief about that. And the other thing is the observability tools and the techniques that we use in order to have tracing. Both are super important, but obviously they're different. You know, back in the old days, when we had only one instance, one application, when you had a problem, you had an exception, and in that exception, you had a stack trace. That stack trace was the flow of the code until something happened. You would have a problem, you would look at the stack trace, and immediately you would understand what happened. And nowadays, when we don't have only one application, one instance, we need the cross-service request tracking. And that actually helps us to understand what is going on with our microservices. Let's say that I have something stuck in the Square microservice. There are at least 3 options of different services trying to send requests to that microservice. I gotta have request tracking in order to understand what exactly is going on. Who initiated the problem? What is the origin of it? So basically, when we're talking about cross-service request tracking, you're talking about having the stack trace of the entire system, having the stack trace of all your microservices. And the other meaning of the word tracing, which we use a lot, is actually those techniques and those tools that we've been talking about in the last 3 days. It's Jaeger, Zipkin, Open Tracing, Open Census, Open Telemetry. I would really like to think about this thing as structured logs on steroids, with a little bit of metrics, a little bit of sprinkles of a lot of metadata, and all of these tools are amazing, but they are not all the time very easy to adopt and to start using. Now, the reality of tracing, as far as I can see, is unfortunately there are too many competing standards and technologies. Even here, when I think most of the people here in the room are observability enthusiasts or experts, being in the first day of Monitorama, the day started with the observation that OpenTelemetry isn't production ready, and 2 hours later, Steve tried to prove that wrong. But the matter of the fact is that right now, if I want to start using tracing, I will take a look at all of those competing standards, and I will try to ask myself, do I need to use OpenTracing? I mean, OpenTracing is stable. It's been there for a long time. I should use it. But no, there's OpenTelemetry. It's new. But is it stable enough? Do I need to use it? It's very, very confusing if you're not like a super SRE expert or monitoring expert. And the next thing is that the paradigms are very, very complex. When I want to come and solve a problem, let's say that I'm a developer, I want to see information that I understand. I want to see things that I know what they mean. A developer that looks into his system and starts seeing things like a trace ID, a span ID, a span, a parent span, a baggage tags. What does all of these mean? And these things are complex. If the day-to-day that you do is not only monitoring, you gotta learn and understand what these things mean. And of course, if you want the promise of knowing everything, you have to pay money. If you want to know everything everywhere about your systems, you need to pay a lot of money. You need to collect a lot of data. And that's very expensive. There is the option of sampling, but if you're starting to sample the data that you get from tracing, then the promise of knowing everything about everywhere that's happening is a little bit broken. And the next is that tracing is hard to adopt. I mean, writing manual instrumentation across all your microservices is not an easy thing to do, especially if you're a polyglot and you need to write that instrumentation in all kinds of languages. There's, of course, the promise of automatic instrumentation, which is really amazing and really, really cool. But it's quite daunting. I mean, I'm going to let someone else change my code in real time. It's a bit scary, and that's my day-to-day job. I change people's code in real time. I know that when something fails, it hurts and it's dangerous. And I'll say a few words later on about automatic instrumentation. Now, don't take my word for it. When you're talking with professionals and people that actually solve the problems, especially engineers and developers, when you ask, what is your go-to tool? What are you looking at? What helps you to solve your problems? Tracing is lagging way behind. And it's not only because not everybody have adopted tracing yet. The information from the survey isn't only about where is tracing available or not. It's about whether you use tracing in order to solve your problems. And tracing is lagging way behind, while metrics and logs are the go-to tools. Now, do we really need to collect so much data? What about all the carbon that we are emitting when we are sending all those tracing all around the network? Now, I talked about a little bit about the disadvantages of tracing, but let's talk about logs. The amazing thing about logs is that we really, really like them. We don't really like to pay about their cost, but we really like them. And why is that? Because they're simple and very, very predictable. The first thing that you do as a developer is write hello world, and there you have it, you've written your first log. They're easy to use. There are actually things written by humans for humans. Humans are writing logs with the target that humans will read them. And you write them very descriptive, and you know that if you have a log line in your code, and that code runs, you will see that log line eventually in the end. So they're very, very predictable. The instrumentation is easy. I mean, all you have to do is just pick some sort of a popular logging library and just use it. There are not many bad options nowadays. Of course, if you're very, very masochistic, you can also just write everything straight into your console without using a logging library, but that's something else. And of course, the analysis is very easy. Because humans have written logs for humans, it's easy to understand what's going on. And of course, if you're actually using structured logging, then you'll be able to index your logs and properly query them and analyze them. And what do we like about metrics? Well, they are numbers. They're very, very easy to understand. There isn't a lot of complex math there, and we really like numbers. I know that 1 may be low, 100 is high, and I can easily understand what's going on with my system. And of course, you can take those graphs, shove them into a graph, take those numbers, shove them into a graph, and immediately understand what's going on. Graphs of matrix are usually really an image that is worth 1,000 logs, or maybe a million logs, I don't know, depends on your system. And they're easy to learn, they're numbers, we all know numbers. And of course, they're very, very cheap. All you're doing is actually taking a small amount of data, taking numbers, and shipping them away. So if we like metrics and logs, why do we need tracing? Why traces came into our life? Well, it's because logs and metrics weren't enough. We always try to search for more data, to understand more what our application is currently doing, understand what is happening in our system. But ever since traces were introduced, both logs and metrics have done a long way. They have evolved. And during the last 3 days in Monitorama here, we saw a lot of examples for it. And we need to remember that we don't need to run and immediately get tracing. We can solve a lot of problems with metrics and with logs. And I'll take a few use cases and see how we can actually solve them with metrics and logs, and we don't have to run and adopt tracing immediately. Okay, so the first problem that usually we're talking about when we're talking about tracing is the lack of context. What's context? What context is understanding the circumstances where the settings of an event happen. Who did it, what did it, when did it? I mean, a context is actually understanding if you see maybe a failure, you want to understand what caused that failure and where it happened. Now, how can you solve a context with tracing? Well, that's basically the promise of it, as I mentioned. But where do we see tracing lacking when we're talking about context? Well, first, I talked about the high costs. It's very, very expensive. Sampling is, again, if you're sampling and you want to understand everything, the context of everything all the time, then sampling misses the goal. And there are complex data structures. As I mentioned, as a developer, if I want to solve a problem, I want to take a look at the information that is very, very relatable to me. It's not easy to write a standard like OpenTelemetry. There is a lot of time invested in the naming conventions of the components, the naming conventions of all the items that you're collecting, and we want to make everything very, very familiar to people who try to use the information. But showing a developer information such as a trace ID or a span ID is practically the equivalent of me walking around Portland, asking a stranger if he can help me out and tell me where I am, and his answer will be a GPS coordinate. If I would have had a GPS, I would use a GPS. I want something that I can relate to. I want a street name, maybe a city if I'm that lost. So we need the information to be very, very accessible to developers. And when something is burning, I don't want to learn new information. I want to have information that is very relatable. So the next issue is the non-applicative context. Trace ID, span ID, that things are not part of my application. I don't know where they came from, especially if I had auto-instrumentation happening. Auto-instrumentation is very, very amazing, very, very cool, but auto instrumentations assumes a lot of things. For example, let's say that auto instrumentations bring me the information about the HTTP request. So I will see http.request. I will see that information. But maybe in my application, that thing isn't called HTTP request. Maybe some other developer, or maybe me, gave it another name. Do I need to really learn what exactly is the equivalent of an HTTP request in my application and in OpenTelemetry? So these things are very challenging. When I want to look at the context, I want something that I can relate to. So we have to use more logs. The first thing about using logs in order to get context is to write high-quality log messages. Log messages such as here, there, or if you're seeing this, there's something horrible happened. Those are logs that make no sense. You have to invest time in order to think about you waking up in 2 a.m. and looking at logs and trying to understand where and what happened. And of course, you have to include relevant variable values. Logs also have the possibility to include values of variables in your application. Things in your production are not behaving different from dev and staging because it's in production, unless you have bit flips and your CPU has problems. But things are acting different because production processes different data than staging and dev. So you have to get information about what data is your application currently processing. And the easiest thing to do to get context with logs, and actually a lot of people don't do it, is build log enrichment. It's very, very easy to automatically insert information that is very much relatable. A file name, a line number, those things are golden when you're talking about context. And if you don't have these things, you gotta have them. And of course, as I mentioned, you have to use structured logging. Yesterday, Joy talked about it. It was written in bold, black on pink. You have to use structured logging. If you're not using structured logging, you're doing something terribly wrong. If you're using structured logging, you can index your logs, you can easily analyze them, easily aggregate them. And of course, you can actually implement cross-service request tracking with your logs. It won't be as robust as using full-blown tracing, but you can actually do it. If you're using structured logging, you can add the source address, destination address, and even unique IDs that will allow you to track your logs. Now, there are real-life examples of adding context into your logs. A few of them are MDC in Java, map diagnostic context, which is pretty much used for that. You can just add something to your thread storage, remove something, and almost all Java logging libraries know how to pull information from your MDC and log them into your logs. And in context, you have the concept of the context object, which is a part of a lot of API calls. I use this a lot of time in Go. I think all Go developers use context. It's idiomatic. It's almost part of the language. And any logging library that you use in Go will probably be able to easily integrate and get data from your context object and write that down. And in Python, we have logger adapters, we have filters. Almost every language has its own alternatives. But what about across services? I mentioned that you can sort of add request tracking to your logs, but it won't be as robust as tracing. So the main questions that we actually need to ask ourselves, whether we really need it all the time. Whether we really need to burn a lot of carbon and get those tracings all the time. Do we really need them? Do we really use them? Now, as I mentioned, tracing promises you a stack trace of your microservices. And try to think about problems that you see when you have a stack trace that are a part of an exception in your code. How often, how many times do you really look at your stack trace to see what happened, what are the steps that has led to that exception? Often you just look at the exception and you pretty much know what happened, because a lot of times our code is very deterministic. Our code doesn't always surprise us. So sometimes you need to really ask yourselves whether I really need cross-service tracking. If I had problems in my Square microservice, yeah, I need to understand who sent what when. There are at least 3 microservices that can send requests to the Square microservice. But if I have problems in requests sent to the Circle microservice, well, only the Square microservice is sending stuff to the Circle microservice. So even if I have problems in the Circle and I have full-blown tracing, I won't really look at the tracing information. I will just know that everything was sent from the Square. So we need to understand how adventurous is the flow of the requests in my microservices. Who can initiate a flow? What can initiate it? Or maybe even when will things be executed? If I know that that requests are sent in a specific time, that I will know who sent it and when because of the timestamps. So I don't really need request tracking all the time. If there are places that I don't need request tracking, I don't really need tracing for that. And the big problem that tracing wants to really solve is getting more data. The promise of tracing, of knowing everything everywhere, really counts on having a lot of data. Now, what can we do in order to get a lot of data? Well, first, metrics. Metrics are cheap, we like them, get more of them. Some organizations only use the very basic metrics of stuff like, I don't know, CPU consumption, memory consumption, etc. These are not enough. You can add custom metrics. You can get your application, create some numbers, add them, subtract them, do whatever you want with them, but you can send them out. Those are custom metrics. And because you have created them, they are very much in the context of your application. You will know what they mean. Even metrics like sending out a metric saying that a specific function is invocated, that's also golden, and you can play around with it. So you can do applicative metrics, and we also yesterday saw a really good example of metrics generated from logs. We saw an example of Loki. The fun thing about it is you're anyway sending out logs, and you really want to get more information from those logs. And cooking up numbers from those logs is very easy. And the fun thing about it is also that you don't really need to have those log-generated metrics all the time, because you can create those metrics in your server. You don't really need to redeploy in order to change how that happens. And when we're talking about logs, logs are expensive. When we want more information from logs, we just get more logs. But volume is different than value. We want to get the right logs in order to understand what's going on. And there are several techniques to do it, to get the right value, and not only by increasing volume. One of my favorite techniques is managing verbosity. When you're writing your logs, you're writing logs in different verbosities. You have the debug logs, you have info logs, etc., etc. Most of us don't run verbosity of debug in production because that will spam us all the time. You don't want to get all the logs all the time from debug verbosity. But those debug logs are amazing. Developers have thought about them, what will go wrong, and actually wrote a lot of data in those debug logs. Many companies implement their own solution of flipping a switch, choosing a server, and telling that server, right now, I want you to give me debug information. I want you to give me debug logs. And when you're done with collecting the data, you can just go ahead and turn that off back to maybe info verbosity. And there are also several tools that you can actually buy in order to accomplish that. The next thing is cold and hot storage. Yesterday we saw good examples of how Slack does that, and that means that you can just collect logs, ingest them, and you don't have to index them. A lot of times, the money goes into the indexing. You don't have to index them. Only when you will be in a situation where you actually need those logs, you can get them out of cold storage, and index them. And of course, you can optimize the volume, remove spikes, drop noisy logs, etc. But the most important thing is that you have to research your needs and act agilely. You don't need to only set up your logs and say, okay, from now on I have, I don't know, retention of 15 days. This is how my logs work. You need to understand which logs you use most, what types of logs you don't use, and you need to all the time change how you consume and how you send your logs. The last use case is investigating latency. Tracing does that amazingly. I mean, if you know what's happening every step of the way and what is the time step of every step, you can investigate latency in a very granular manner. So how can you do that with logs and metrics? Well, it might sound funny, but you can just use the time step of your logs. Of course, it's not as amazing as tracing, but you can just start with metrics. And if you have the right value, the right information from your logs, just take a look at the timestamp of your logs, subtract them. I know sometimes it seems like a very, very funny way to do it, but it actually works. And developers that even use tracing do this all the time, but it really depends on the quality of your logs, whether you have logs in the right places or whether you got the logs from the right place. There are also solutions for live profiling or demand profiling that you can use. Now, to recap things, I don't hate tracing. I hope you don't think that. Tracing is awesome. It's really, really amazing. But we really don't need to get tracing because all of the cool kids are using it. Not everyone is Slack or Uber or Facebook. Tracing is expensive. And we need to use tracing only because we understand that we need it and that we actually know how to use logs and actually know how to use metrics. Now, we love logs, we love metrics. We need to improve how we use them. We need to adapt to them. We need to all the time ask ourselves whether we're using them in the right manner. And of course, the last thing is that we really need to understand how to make tracing more accessible. Yesterday or 2 days ago, we had a talk about making your application accessible to people with disabilities. But we really need to make tracing accessible to people who don't know tracing. And we still have a long way to go.